Pluto, the mysterious dwarf planet that lies at the very edge of our solar system, has always been a subject of intrigue and fascination. But recent developments have added an ominous twist to Pluto's tale, a twist that could have far-reaching consequences for our solar system and perhaps even life on Earth. From the moment it was discovered, Pluto's orbit was a puzzle, crossing paths with Neptune in a way that defied the norms of celestial mechanics. This small, enigmatic world, once celebrated as the ninth planet of our solar system, has sparked a new wave of excitement and concern among astronomers and space enthusiasts. Notable figures like Neil deGrasse Tyson and Michio Kaku have recently sounded alarms, warning of a potential cosmic event that could change everything we know about our solar neighborhood. But how did Pluto interact with Neptune? And what does this celestial encounter mean for the rest of the universe, including our planet? As we uncover the mystery surrounding Pluto's orbit, we delve into the complex mechanics that govern its journey through space, the possibility of a catastrophic collision with Neptune, and the results of that event on a global scale. Join us on this journey to explore the dark corners of the solar system, where a massive cosmic collision is taking place, worrying scientists around the world. When Pluto is known as the ninth planet in the universe, it is still a stranger. The discovery in 1930 by Clyde Tombaugh added a new chapter to the history of our solar system. But Pluto's position as a planet was short-lived. In 2006, it was designated a dwarf planet by the International Astronomical Union (IU). This reduction is mainly due to its small size and unusual orbit, one that brought it into the orbit of one planet, Neptune. Although Pluto has lost its planetary status, Pluto has not ceased to fascinate astronomers and the general public. Its remote location, unique features, and near-term concerns about its orbit keep Pluto at the center of astronomical controversy. What is it about this distant world that is holding him back after he downgraded his power? One reason is the complexity of Pluto's orbit. Unlike the 8 major planets, which follow circular orbits around the Sun, Pluto's orbit is perfectly circular, at an oblique angle compared to the plane of the Sun. This unusual orbit has puzzled astronomers since its discovery, and has led to many theories about its origin and interactions with other celestial bodies. That Pluto's journey around the Sun is unlike any other planet in the solar system. While the larger planets, including Neptune, follow circular orbits, Pluto's path is different. It takes Earth 248 years for Pluto to complete one orbit around the Sun, a journey it has not completed once since its discovery in 1930. That the orbit of Pluto enhances her beauty. Rather than a perfect circle, Pluto's orbit is an elongated ellipse that resembles an ellipse. This means that Pluto's distance from the Sun varies as it travels. At its closest point, known as perigee, Pluto is about 30 astronomical units, AU, from the Sun, sometimes even closer to Neptune. At its farthest point, or aphelion, Pluto is more than 49 Australian dollars, about twice as far from the Sun as Neptune. But it's not just the shape of Pluto's orbit that divides it. This is another fantasy. Pluto's orbit is tilted at an angle of 17 degrees relative to the plane of the ecliptic, the flat, disc-shaped area where most of the planets in the solar system are located. This preference means that Pluto's path through space will go up and down the orbits of other planets, adding layers of complexity to its unusual journey point. One of the most interesting and disturbing aspects of Pluto's orbit is its connection to Neptune's orbit. At about 20 years per orbit, Pluto is closer to the Sun than Neptune, a phenomenon that defies the traditional order of the solar system, in which the planets are arranged according to their distance from the Sun. This crossing of paths begs the question, why didn't Pluto and Neptune collide? Finally, their paths cross in a way that puts them on a collision course. The answer lies in the subtle dance between the two celestial bodies, a dance that has been going on for billions of years. The key to this cosmic dance is a phenomenon known as orbital resonance. Pluto and Neptune are locked in a 3:2 resonance, meaning that for every 3 orbits Pluto completes around the Sun, Neptune completes exactly 2. This resonance ensures that whenever Pluto crosses Neptune's orbit, the two planets are always far apart, preventing any possibility of a collision. But while this orbital resonance has kept Pluto and Neptune safe from each other for billions of years, it's not a foolproof system. Gravitational interactions with other planets, particularly Jupiter, could gradually alter Pluto's orbit over time, potentially disrupting the delicate balance and leading to a close encounter, or worse, a collision, with Neptune. The intricate dance between Pluto and Neptune is a testament to the power of gravity, the invisible force that governs the motion of celestial bodies throughout the universe. The force of gravity keeps the planets moving around the Sun, but it affects how they interact with each other. Sometimes unexpectedly, Pluto's orbit is very sensitive to the pull of the giant planets, especially Neptune and Jupiter. These forces can cause small but significant changes in Pluto's orbit over long periods of time, resulting in complex and frequent orbital behavior. One of the most interesting features of this powerful keyboard is the azimuth outlay feature. This aspect helps keep Pluto in its 3:2 transit to Neptune, ensuring that their orbits remain stable and collision-free. Azimuthal summation is like a celestial metronome, adjusting Pluto's orbital period so that it doesn't get too close to Neptune. Another important factor is latitude, which ensures that when Pluto approaches Neptune, it will be safely above or below Neptune's orbital plane. This vertical separation is important to avoid collisions because it means that even when their orbits cross, Pluto and Neptune are not in the same place at the same time. Despite the stability of the azimuth and latitude libraries, Pluto's orbit is not completely predictable. This is a perfect example of orbital chaos, a phenomenon where slightly different initial conditions lead to different results over time. In the late 1980s, computer simulations of Pluto's orbit showed that the orbit was chaotic. Even a small change in Pluto's initial position or velocity can lead to a very different orbital path over millions of years. This unpredictability is a characteristic of chaotic systems, where small perturbations can have large and multiple unintended effects. For Pluto, this means that although its orbit has remained stable for billions of years, there is no guarantee that it will remain so forever. The forces of Neptune, Jupiter, and other distant objects in the Kuiper Belt could push Pluto out of its current orbit, possibly causing a catastrophic collision with Neptune. Although a Pluto-Neptune collision is unlikely, it is not impossible. If that happens, it will have big consequences not only for the two planets that exist, but for the entire solar system. A collision between Pluto and Neptune will release so much energy that Pluto may break into many pieces. These fragments can be launched into space, posing a threat to other planets, moons, and even spacecraft. Some of the debris reaches the Kuiper Belt, where it helps create new material, while other pieces are pulled into the solar system and crash into Earth or other planets. But the result of that encounter was not limited to physical blows. The perturbation of this collision could change the orbits of other planets and cause global changes. Even a small change in the orbit of a planet like Neptune can have a huge effect, disrupting the entire system. Although the direct impact of a Pluto-Neptune collision on Earth is minimal, the indirect effects may be significant. The gravitational disturbance from this collision will affect the atmospheres of other planets, including Earth, and may cause long-term changes to the planet's climate and environment. One of the consequences is a change in the Earth's orbit, which can change the length of our seasons or change our entire climate. These changes can have a significant impact on the world, especially if they occur over a short period of time. Although the probability of this happening is small, it is a reminder of the interconnectedness of the solar system and the delicate balance that it always maintains.